In this session, I'd like to explain the collisions. We have two types of collisions, elastic collisions and inelastic collisions. Elastic collisions, total kinetic energy is conserved when the internal force is conservative. In the case of the inelastic collisions, the total kinetic energy decreases after collisions. Some kinetic energy is lost as heat. So one special type of the inelastic collision is a completely inelastic collisions. Bodies have the same final velocity after collision. Two objects collide with each other and become the one object. This is a completely inelastic collisions. So we are going to study this special case of the completely inelastic collisions. Bodies have the same final velocity after a collision. So before collisions, m sub b doesn't move, and m sub a has a velocity of the v sub 1 and approaching to the object with the mass of the m sub b, and hit the object m sub b. After the collision, two objects stick together to have a final velocity of the v sub 2. We consider these two objects the system. Then, as I explained, we could apply the conservation law of momentums because there is no external force acting on these systems. So before the collisions, momentum is expressed m sub a v sub 1. And after collisions, m sub a and m sub b has a v. So momentum is expressed these expressions. Then from this equation, you can derive the speed of an object. Is v sub 2 is expressed m sub a over m sub a plus m sub b times v sub 1. So in case of the elastic collisions, one of the particles is coming, and during the collisions, actually kinetic energy is transformed into the elastic potential energy. These two objects is deformed. Then after the collisions, elastic potential energy is reconverted to the kinetic energy, and the object is start moving after the collisions. So we consider special case. In this case is one body initially at rest. So before collisions, m sub a has a velocity of the v sub a1, and m sub b doesn't move. And after the collisions, m sub a has a velocity of the v sub a2, and m sub b has a velocity of the v sub b2. So we'd like to find out this v sub a2 and b sub b2. We consider that this is the side of the system. Then there is no external force. Then we can apply the conservation law of momentums. This is the conservation law momentums. So left hand side is before collisions, and the right hand side is momentums after the collisions. Kinetic energy has to be conserved because this is elastic collision. So before the collisions, kinetic energy is expressed 1 over 2 m sub a times v sub a1 squares. So this is before collision. And after the collisions, 1 over 2 m sub a v sub a2 squares plus 1 over 2 m sub b v sub b2 squares. So we have two unknown values, v sub a2s and v sub b2s. If you look at the practice 3.7, you will understand how to solve these problems. The answer v sub a2 is m sub a minus m sub b over m sub a plus m sub b v sub a1. V sub b2 equal to m sub a over m sub a plus m sub b v sub a1. So if you're interested in how to get this equation, please refer to the practice 3.7 and watch the videos. I explained how to get these answers. Okay, this is the end of this session.